Yesterday we had a tech talk on arc flash reduction, methods to reduce incident energy, and I had 6 ideas I brought to the table. Well, what I completely forgot about is a critically important piece of the safety puzzle, and I had to take some time today during lunch just to revisit this discussion because again, it's a very important part of arc flash safety and incident energy reduction, all this other good stuff. Remember yesterday during our discussion, one of my topics, the very first idea I put on the table was to facilitate the electrically safe working condition. 70E speaks to this in both the latest version, the 2021 version, and the 2018 version. You're never going to see that topic being removed from 70E because it's all about establishing that electrically safe working condition. So what it's looking at, hold on, there we go. So in any case, the what I forgot to leave out, remember we talked about the disconnects last week or yesterday. We talked about making it available, making it easy to establish an electrically safe working condition. And so that was my whole gist of the first topic. But what I forgot was the single line diagram. A lot of people, shirt, tie, and jacket, baby. So a lot of people, hey Terry, good to see you, buddy. A lot of people forget about the importance of the single line diagram. The single line diagram is plays an important role in electrical safety, but just like I did yesterday, it falls off of the table. It's the last thing that's done. Hopefully you had to have a one line diagram probably to bid a job or specify, show the layout of the diagram and show your power distribution system. But it quite often, probably more often than not, does never get updated. We have this thing called as-built diagrams and as-built drawings, and the reason we have that is because changes occur during installation. Rerouting conductors in a power distribution system makes a difference in incident energy. Why? If I add lengths of conductor, I could reduce the available fault currents, and I have an increased incident energy. Well, so understanding the layout of the system, the layout of your power distribution system is very important for the electrical worker. And so what I wanted to do, and I have a program on my YouTube site where I focus on the single line diagram, and I go through, there's a misconception that it's a code requirement and all this other good stuff. So I go through the National Electrical Code, I go through 70B and 70E, and I try to highlight the areas where the single line diagram is important. Terry, yeah, finding those errors is really important, and making sure that we follow through to get them updated. So if I look at the National Electrical Code, and if I think about the single line diagram itself, you know, these diagrams, everybody puts something a little different on their single line diagrams. Some people will put all of the information with regard to the conductors, the available fault currents. I've seen single line diagrams that did not have available fault currents. I've seen single line diagrams that did. It really depends on the complexity of the diagram. But what's really important for the electrical worker is to know if they're going to establish an electrically safe work condition. For example, for this transformer, in this diagram I have here, this transformer 2, this T2, if I'm going to work on T2, I need to know what breaker feeds or fusible disconnect feeds T2. So where do I go to find that? I find that information on my single line diagram. Years ago, I did a project. I was doing a short circuit study at a plant down in Tennessee. And when I went down to the plant, I always do a walk down of the facility. I take my one line diagrams and I would walk the facility down, and it was an industrial facility, and I would just try to find the equipment. And I'm walking around looking for a motor control center. I could not find this motor control center. It was on a mezzanine. I went on every mezzanine. Finally, there was an electrician sitting there, and he was eating his lunch, I think. And he goes, "What are you doing?" I said, "I'm looking for motor control center 3AB or whatever the number was." He goes, "Let me see that drawing." And he looked at the drawing and he goes, "Boy," he says, "we took that motor control center out back in the 70s. And I'm looking at my drawing, and my drawing dates were like in the 70s. So, and they have never been updated. So part of my short circuit coordination, and well, this was before Arc Flash was was what it is today. But before I could even do my study, I needed to go back to the client and say, I need more money because we're going to have to update the one line diagrams. They've never been updated. So that was just for my fault current calculation and my selective coordination study that I was doing. Now throw into the mix an incident energy analysis. Okay, when your power distribution system changes, you need to keep that one line diagram updated. If you bid a project and you got that order, make sure you put in the bid money to update the one line diagram, to create as-built diagrams. And don't not spend that money when you get that order. Because here's what happens. You get towards the end of the budget, you get towards the end of the project, and you go, no one's going to ask for these one-line diagrams anyway. And you know what? I got them from the beginning of the project, and yeah, we updated them a couple times, but I'm not going to update them, and I'll let the customer worry about it. You can't do that. Important for the electrical worker. So in the National Electrical Code, we have 490.25 backfeeding. And you know what? I grabbed this from another PowerPoint presentation. I just want to make sure in my book. Now I've gone through the National Electrical Code a while ago when I did my other program, and this is the only reference I could find to a single line or a one line diagram. Now, everybody refers to it differently. Some people call it a single line diagram. Some people call it a one line diagram. 490.25. I'm looking in my 2020 code book. Backfeed, yes. Installations where the possibility of backfeed exists shall comply with 490.25A and B. A is sign. A permanent sign in accordance with 110.21B shall be installed on the disconnecting means enclosures immediately adjacent. And then diagram. This is 490.25B. Diagram. A permanent and legible single line diagram of the local switching arrangement, clearly identifying each point of connection to the high voltage system section shall be provided within sight of each point of connection. That's the only reference. Now, if you know of any other references, Mohammed, Terry Becker, anybody out there, if anybody out there has another reference in the National Electrical Code where a one-line diagram is referenced, please put it in the chat because I can't find it. That's the only location I know of. Now, 70E, obviously, 70E is where we find the definition, and I'm going to read out of the 2021 version, which is the latest version, and that would be Article 100 for single line diagram. Single line diagram, and it says, you know I'm getting old because I can't see. Single line diagram, a diagram that shows by means of single lines and graphic symbols the course of an electric circuit or system of circuits and the component devices or parts used in the circuit or system. Now, it doesn't tell you everything that needs to be in a single line diagram, and I know everybody includes various levels of details on their single line diagrams. But suffice it to say, 120.2 lockout tagout. And I know that 120.2, I used this is based on the 2018 version, not the 2021 version. So these numbers did change a little bit. They moved some things around on the 2021 version. Lockout tagout, obviously. I can't lock and tag out a piece of equipment. We talked about disconnects yesterday. Well, what about lockout tagout? If I don't know where the disconnect is or where the overcurrent protective device is that feeds the equipment I'm going to work on, how do I know where to lock and tag it out? And I might have multiple devices to lock and tag out to establish an electrically safe working condition. So your one line diagram is critical. 205.2. I love it. Okay, I don't know if anybody else out there got one of these, but look at this book. Okay, it's upside down. The entire contents of this book are upside down. I got to go like this to read this book. And the back of the book is the front of the book. Anyway, I'm keeping it though because I'm going to sell this on eBay in a while and whatnot. But in any case, 205, chapter 2, section or article 205 is general maintenance requirements. So general maintenance requirements tells us a single line diagram where provided for the electrical system shall be maintained in a legible condition and shall be kept current. So here's the thought. Everywhere in 70E where they reference a one line diagram, let's put it this way. Nowhere in 70E does it say you shall have a single line diagram. Every reference says, like this says in 205.2, a single diagram where provided. And if I go to 120.2, it doesn't quite tell you exactly. Let's read 120.2. 120.2, lockout, tagout. Where's it at? Coordination, forms, lockout, tagout procedures. I'm just looking to see where exactly in here, and I can't find it really quick. But yeah, there it is. It says a lockout tagout procedure. This is in C, 120.2C. A lockout tagout procedure shall be developed on the basis of the existing electrical equipment and system and shall use suitable documentation, including up-to-date drawings and diagrams. That's all it says is up-to-date drawings and diagrams. So in any case, 70E, there are numerous references, but again, the one line diagram helps facilitate the establishing an electrically safe work condition. Now, how about 70B? 70B, remember 70B in its current form is in a you could or you should or it would really be nice. 70B is moving to a standard. It's going to be a you shall document. We're in the process right now. 120.512. 120.5. Sean McCarthy. 120.5. 120.5. And I don't know if that's an NEC reference. 120.5. 120.5. 120.5. 1, 2. I'm not sure what that reference is, Sean. So, Sean McCarthy, if you can let us know. Hey, Felix, good to see you, buddy. Good to see you. And that's online, so that's on. I'm not sure. So here's the other thing I'm doing. Let me know if you're on YouTube, LinkedIn, or Facebook, because I'm streaming all three platforms. Thanks, Sean. So 120.5 is. Are you looking, Sean? Are you looking at the 2018 or 21? 120.5. 120.5. 1 and 2. 1 is determine all possible sources of electric supply to the specific equipment. Check applicable up-to-date drawings, diagrams, and identification tags. That's another good reference. Up to date. You got to keep the one-line diagrams up to date. Facebook warned you, and you went to YouTube. Sweet. Thanks, Felix. So that's another. It's very important is to make sure that your one-line diagrams are up to date. Now, 70B. 70B has chapter 6, and it talks about diagrams and data in 6.2.2, and 6.2.2.1 talks about the single line diagram should show, and basically what they should show. But keep in mind that 70B is moving to a standard, and I call it the trilogy. 70, 70E, 70 is the National Electrical Code, 70E is Safe Work Practices, and 70B is maintenance. All three of those work together to help you create a safe installation for the electrical worker and for anybody else in that facility. So that was my, I want to make sure I have it all. Yep. That was what I forgot yesterday. And I thought I would just really quick go live today. And what I wanted to do was stream to 3 platforms. So I don't know if I was successful there. I'm just going to check my Facebook page. I'm going to stop my audio so I don't screw that up. There it is. So okay, yeah. So I am on Facebook. Michael Johnston. That's not the latest edition of 70E. Just saying. Oh, babe, Michael, I got them both, buddy. Got them both. So so I got Facebook. I got let me just double check my LinkedIn. Okay, so I just want to make sure. Let me check my LinkedIn site. Make sure I'm live there too. I don't know if I am or not, so I'm just checking. Yes, I am. Perfect. So I'm live on Facebook, LinkedIn, and Felix is watching on YouTube. So I've got to be live on YouTube. All right. So remember, in 70E 2018, 2021, the one-line diagrams are critical for safe work practices. If you missed the program yesterday, I'm going to go live every Tuesday, 12 o'clock, hopefully every Tuesday. I'm on a few committees, and if we meet at that time, then I can't. But every Tuesday at 2 or 12 Eastern, check it out. We're going to talk electrical safety. Next week is talking OEMs, OEM options, providing options for your customers, and how important that is, and how the National Electrical Code and other codes and standards may throw a wrench in requiring you to have options to meet some of the latest changes and requirements in the National Electrical Code. So in any case, check out my YouTube channel as well. I have a whole session on the one-line diagram, the single-line diagram. I go into detail on the requirements that are found in 70E, and I believe that program I did on the 2018 70E version, I will be updating that for the 2021 version of 70E, and I'll be doing that here shortly because I've got a customer, an electrical contractor, who wants me to do that same program talking about 70E, and I plan to make sure that I update that for 2021 version. All right. Okay, so I appreciate you guys dialing in and watching. And remember, Pound EATON Tech Talk will get you all of my live events. Don't forget, I do have some live events every Tuesday. So what I think I'm gonna end up streaming all of those to all 3 platforms. So, but sign up for and everything's free. So just sign up for next week's program, and I'll see you tomorrow night on my YouTube channel. What we're going to do tomorrow night, I went through and did a presentation on a live working session on the manual calculation of fault currents. So what I'm going to do tomorrow is we're going to take this single line diagram, and we're going to pick all of our overcurrent protective devices. We're going to possibly get into the discussion of selective coordination as well. So I appreciate you dialing in and checking this out. And I wanted to make sure that I updated you because I left that out yesterday. Single line diagram, this diagram, really important for electrical safety, for the electrical worker in establishing an electrically safe working condition. Thanks for what you do for the electrical industry. Thanks for what you do for electrical safety. Remember, stay safe and please stay healthy. I'm going to sign off. See you tomorrow night, 5 o'clock p.m. Eastern on YouTube, or I will see you Tuesday next week, 12 o'clock noon, 1 o'clock open discussion about providing solutions and options for our customers and how that can help you avoid costs in the field due to red tags and help you increase safety. Alrighty, thanks again, and take care, stay safe, stay healthy. See you later.